Assalamualaikum warahmatullahi wabarakatuh. My name is Yusuf Adli. I and my team members have been chosen Alzheimer as our group presentation. For the introduction, I will explain about the definition of Alzheimer disease and also the possible method to diagnose the disease. So what is Alzheimer? Alzheimer is the progressive disease of mind memory loss. It is a common type of dementia which is impairment of cognition, and it becomes difficult to make conversation and also doing daily activity and difficulty in responding to environment. Here's the difference between normal brain and also the Alzheimer disease brain. For the possible method to diagnose Alzheimer, we have divided into two parts, which is imaging and non-imaging. For imaging, we have MRI scan and PET scan. For the non-imaging, we have interview session and also neuropsychological tests. For the imaging method of MRI scan, will give more better and detailed image rather than PET scan. And for the non-imaging method, we have a neuropsychological test to test the patient speed, memory, attention, focusing, creativity, and flexibility.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Ismail. So I'm going to present about imaging modality for our case, which is Alzheimer. So imaging modality is categorized by a type of medical imaging technique in which the image are generated. Okay, so there are three reasons why I'm choosing MRI. The first one is MRI can detect brain abnormalities associated with MCI, which is mild cognitive impairment. So MCI is the early stage of memory loss or other cognitive ability loss such as language or also visual. So the second one is MRI can be used to predict which patient with MCI may eventually develop into Alzheimer's disease. Okay, so the third one is in the early stage of Alzheimer's disease, an MRI scan of the brain may be normal, but in later stage MRI can show a decrease in the size of different areas of the brain. Okay, so this is the two examples, which is the left one is the pictures of image that being diagnosed by MRI for the healthy normal person. So for the right one is the image diagnosed by MRI for the patient who are suffering from Alzheimer. And then there are three types of imaging technologies used in Alzheimer research, which is structural imaging, functional imaging, and also molecular imaging. So structural imaging, where it can provide information about the shape, position, and volume of the brain tissue. So in the functional imaging, it reveals how well cells in various brain regions are working by showing how actively the cells use sugar of oxygen. Okay, for the third one is for the molecular imaging. So basically for the molecular imaging, it uses high targeted radio stressor to detect cellular or chemical changes linked to the specific disease. So from all these three types of imaging research, MRI will be used. Thank you so much.
So next we'll be discussing on imaging technique and procedure. So the main components of an MRI scan is the radio frequency coils, the gradient coils, and a superconducting magnet. So water is actually a molecule which is made out of hydrogen and oxygen, and it is approximately 2/3 of a person's weight. So the hydrogen protons are aligned by an external magnetic field and is disrupted by the RF energy. The nuclei will release an energy and the emitted signals will be measured. Fourier transformation will convert the signal's frequency information from each point in the scan plane to matching intensity levels, which will be then represented in pixels. Different forms of images can be formed by altering the sequence of RF pulses applied and collected. Tissues are characterized into relaxation times, which are longitudinal relaxation time T1 and transverse relaxation time T2. So proton's internal revolution will generate a magnetic moment. It operates as a magnet with north and south poles. The orientations of the magnetic moments are usually random since there is no strong magnetic field. When in the presence of a strong magnetic field, the magnetic moments will align at an angle to the magnetic field direction. Some protons will align parallelly and some will align anti-parallelly while still spinning around on their own axis. Usually, a lot of protons will align parallel, but there's more protons that are aligned parallelly. So the magnetic field from the protons will cancel each other out to leave only the magnetic field from the small proportion of extra parallel protons. The protons are then disrupted out of alignment from the scanner's magnetic field using an RF pulse. The frequency from the RF pulse will match the frequency of the spinning protons in order for them to exchange energy and be in resonance. The protons will then absorb the energy from the RF pulse to resonance to rotate their axis away from the magnetic field, allowing the scanner to measure it. So if we want to scan a specific region of the body, for example the brain, a second magnetic field is used. Protons will then spin quicker in the region than in other parts of the body. So the RF pulse will only be resonant with those protons if it is tuned to match the frequency of protons in the target area. As a result, only the protons in the target area will absorb the RF pulse energy and be flipped away from the main magnetic field. So the protons that flip back and realign along the main magnetic field when the RF pulse is shut off. The protons will then give out an energy as they flip back and realign. The amount of energy released by different tissues in the body will be different. A coil is placed around the body part where we are imaging to measure the radiated energy. The coil serves as an antenna that will detect the energy emitted as an electric current. Using Fourier transformation, the electric current is then converted into an image on the computer.
Hello, today I'm going to talk about the protection and safety of an MRI machine. Okay, let's start with pregnant women. So MRI is reserved for use in pregnant patients only to address very important problems or suspected abnormalities. For breastfeeding women, you should actually inform the MRI clinic that you are breastfeeding when scheduling for your MRI exam. This is particularly important when you receive the contrast agent. So as for claustrophobic patients, mild sedative is given to them to remain calm, and they are permitted to have family members to be present all the time. And as for contrast agents, gadolinium containing contrast agents may increase the risk of patients with severe kidney failure. Okay, so as for hearing protection, the MRI produces a strong magnetic field. So each pulse makes the coil in the MRI to vibrate and create loud noises. So to avoid this, we are given earplugs or headphones. Next, we must avoid metallic objects while in an MRI because this can attract metal and cause risk to patients. Next, we need to inform if there's any implantations. In some unusual cases, due to the presence of an unacceptable implant or device, the exam may have to be cancelled. And the last one, we need to wear proper clothes because clothes may contain metallic threads or metal-based antibacterial compounds. So we need to avoid that. Thank you.
Next, weakness in MRI. First, expensive and time-consuming. An MRI is a very expensive and time-consuming investigation compared to other methods such as X-ray and CT scan. Some part of body like bone are better examined using simpler techniques such as X-ray. Second, difficulty in differentiation. An MRI may not always be able to tell the difference between some disease processes. It can make doctor difficult to diagnose the diseases. Third, loud knocking noise. The magnetic field that changes with time causes loud knocking noise that may be harmful for hearing if ear protection is not used. They may also cause peripheral muscle or nerve stimulation that may feel like twitching sensation. Fourth is radio frequency energy. The radio frequency energy during MRI scan could lead to heating of the body. The potential for heating is greater during long MRI examination. Thank you.